Remember I said calculus is turbo algebra. What was the first formula you learned in algebra? Can anybody think back that far? You would think, but you have to define something part of that equation. Slope. Because yeah, y equals mx plus b is the first formula where you're going to deal with, but the slope, the m. What is a slope? I know. It's the algebra that's going to kill us. Okay, what does that mean? Okay, we're getting closer. But that's only part of it, really. It's rise if it's positive. It's if it's negative, it goes down. Yes. But besides, it's not y over x. Can anybody, for bonus points, try to figure out what it's supposed to be instead of y over x? Okay, you're getting closer. Now, how do we represent it like this? That's the formula for it. That's the formula for slope. How do we represent that using symbols? Delta. Right. Very good. Very good. Delta y over delta x. This is what we just labored to define, actually. We have 2 points. And we figured out the slope from there. If you think about it, what formula are we using to figure out the slope? Or what else can we use the slope for? Find the hypotenuse, which is what in this case? No, yes. So here's the hypotenuse, which is C. But what does that really define for us? What does the hypotenuse really tell us? Because here we have delta x, here we have delta y. What the hypotenuse really tells us is the distance between points A and B. The hypotenuse is the distance from point A to point B. And this is what we call the slope. So we have delta y over delta x, which is what we look at as called the rate of change. Why is it a rate of change? Think of it this way. Let's say, well, whenever you deal with, how many of y'all took physics before? The x-axis is always what variable? Time. So this is time. So from time 1 to time 2, whatever happens within this time interval is whatever we're looking at. Let's say this is growth of some object. Or we could look at it as a position function. Here's this position at this time. Here's this position at this time. So if we think about it, if we're looking at positions, let's say this is in miles. What have we just figured out? We have the distance in miles over the time period, seconds. What do we call that? Not really velocities yet. Speed. The speed, what we're going to talk about, there's a difference between speed, velocity, acceleration, and jerk. And all those are built on each other. But this works great in a Lego world or Minecraft world. Why? Is everything straight? What if we have a curve? What if we have a curve? Is our slope, the rate of change, is that the same? If we have a curve, what does this equation find for us? Yes, it's the shortest distance between 2 points, yes. But what is it called? What kind of slope of line of what kind of line? It is, but no. This equation finds us the slope of the line as a secant line to the curve, to those 2 points. What we want, if we have a curve, we want to know what is the slope at that point. What is the slope? Instead of slope, what we mean is the rate of change at point 1 or point A. What is the rate of change at the point there? So what we're looking for here, so this is the secant line. What we want to know is what is the slope of the line tangent to the curve at that point? The slope of the line tangent to A, to the curve at point A. That's what we're looking for. How do we do that? Now, what we've done so far, this is not a bad formula. Yes. Let me make a better picture. So here we have. That's better. Here we have 2 points. The secant is the line that goes through points A and B. That's the secant line. So this is time 1, this is time 2, y1, y2. Now, what we've talked about so far this is not a bad formula. It's called the average rate of change formula. But we just look at the entire picture. But if we want to know the rate of change of that point there, of the tangent, we want to know the instantaneous rate of change. And trust me, you've done that too in algebra. Let's see how we did that in algebra. Hmm? One more time. What's that called?
Differential. It's quotient.
Yes. What happens here is this. What we have to know, we want to know what is the slope of that point there. What that means is we have to move this point from there, we have to move it to here. Because we can only have 1 point. The graph is only being crossed at 1 point. So this distance we call h. If you think about it, if I started off with some value t1, how do I get to t2? Well, I start off at t1 and I add h to it. Right? If that's h. So if this was 3 and h was 5, what is this value? 8. 3 plus 5 is 8. All right, so now what I'm doing here is now I want h, the distance between these 2 points, I want it to be smaller. So instead of, I want it here, I want it to be over here. So this is the slope of the line there I want. Now I want it here. I want it here. So you see what's happening every time I pick a new x value. The slope is getting more and more from the secant to the tangent line. When will they be equal? When what happens? When what's true? When will the secant line be equal to the tangent line? The slope of the secant line will equal the slope of the tangent line when h is equal to 0. So when h is equal to 0, that means that, well, what is h? What's the formula for h? We have T2 equals T1 plus h. So h is equal to T2 minus T1. And we have these two. And now we have h. Let's build this. So we know the slope is equal to y2 minus y1, x2 minus x1. We introduced functions in algebra. So we have f of x2 minus f of x1 over x2 minus x1. Well, instead of x, we use time. So we have f of t2 minus f of t1 over t2 minus t1. So far, so good? We're just using the same slope formula. So what is t2 minus t1? t2 minus t1, we define that as h. What is t2? t2 is t1 plus h. So it's f of t1 plus h minus f of t1. Because remember, we only want the slope at one point. We only want it at t1. So there is our instantaneous rate of change, or the difference quotient. If you remember from algebra, the difference quotient found the slope of a line, the slope of a curve at any given point. Let's practice this from algebra. Okay, here's an example. F of x equals 3x plus 2. Find the difference quotient. Which is f of x plus h minus f of x all over h. That's the difference quotient. So in order to use difference quotient, what do we have to find first? Yeah, we need to have an f of x plus h. We have f of x here. To find f of x plus h is anywhere we see an x, we put an x plus h. So anywhere we see an X, we put an X plus H. All right, so the difference quotient is f of x plus h minus f of x over h. F of x plus h is this entire thing. 3x plus h plus 2 minus f of x, which is 3x plus 2. I remember from algebra, it said in a difference quotient, any part of the equation after the minus sign, when you simplify it, has to disappear. So when we remove the parentheses, so we have 3x plus 3h plus 2. This minus sign goes before, so it's minus 3x minus 2. Remember, everything here has to disappear. Negative 3x and 3x cancel. Negative 2 and 2 cancel. And the h's cancel, so the difference quotient tells us 3. So what does that tell us? We got a number. What does that tell us? That's the slope of the line tangent to the curve at that one point. But it's a 3. And it's a constant slope. Well, duh. What kind of equation is this? It's a linear, so it's going to be a constant. What's the slope? 3. We do that to check, make sure our process is correct. So that works. So let's go with something better. Find me the difference quotient, or basically find me the slope of the line tangent to the curve at slope of line tangent to f of x at the point 212. So whenever you're asked to find the slope of the line tangent, that automatically tells you have to use what formula? The difference quotient. By definition, the difference quotient finds the equation of the line tangent to the curve. So let's find the difference quotient, which is f of x plus h minus f of x all over h. So we need to find an x plus h. So what's the first thing you gotta do?
Where X plus H.
The square x plus h. So x plus h squared becomes x plus h times x plus h, which is x squared plus 2xh plus h squared. Foiling. Okay with it? Yes. Yes, of course, of course, of course. Let me okay, don't ignore that. Okay, so that means these two are there. Basically, everything in the first parenthesis multiplies to everything second. So the x's. X times x is x squared. X times h is xh. Now the h. H times x is xh. Xh, hx, something. And then h times h. And combine like terms. Yeah. So now we plug that inside there. Well, I'll go ahead and just the difference quotient. I'll go ahead and work that out. So it's f of x plus h minus f of x over h. F of x plus h is this whole, I need the bigger room. So it's going to be this, that's the first part, x squared plus 2xh plus h squared, that's that, plus 3x plus 3h. This is going to be x plus h squared minus x squared plus 3x plus 2. So we got rid of the first part, x plus 8 is that big one. 3x plus 8 plus 2 minus, now I distribute, so I put a negative in front of each of these. Simplify. The x squared, x negative x squared cancel. 3x negative 3x cancel. 2 negative 2 cancel. So far, so good. Now what do we do on top? Well, I factor out the h. Since they all have h's on the top, I factor out the h, which gives me 2x plus h plus 3. Cancel out the h's. So 2x plus h plus 3. Sorry, it's my big old head's in the way. Are we done? No, because what does h become for the difference quotient to work? Has to become 0 because the 2 points have to be the same value. So h is x2 minus x1. So that disappears. So our answer becomes 2x plus 3. This is my slope at any point along the curve. And you notice how it changes. Why is the value always going to change? And what else? Well, yeah, it changes. Yeah, yes. Because x is a variable, but why is there a variable left inside our answer? Yeah, and because the graph of the function is going to look like what? It's a parabola. Depending on which x value you put in there, it could be negative over here, it could be 0 here, and then positive there. So depending on which x value you pick, the slope changes no matter which x you pick because it's tangent to the curve at that point. And not to ruin the surprise, but what we've just done is found the first derivative. This is what's called the rate of change, the first derivative of a function of calculus. You did this in algebra. Let's take some examples of instantaneous and average rate of change. Yes.
Why did we cancel the h?
Because remember, for a function, for a secant line to exist, we need only one point. We need to have a tangent point, which means this h value here has to go to 0 so that the end point and the beginning point are the same value. Okay. A rock falls from the top of a tall cliff. What is the average, let's say speed? A. During the first 2 seconds of fall and during the 1 second interval between 1 and 2 seconds. So, was the question telling us what? Average speed. So, what formula are we going to use there? Which one? The difference quotient is also a slope. The original one, right? So, average speed will be the position make that t. F of t2 minus f of t1 over t2 minus t1. Here's a picture of it. A rock. It falls. So what do we know here? What values do we have for our equation? Well, T1 is what? And T2 in the first one is 2 seconds. What about the position? What's F of T? It's a falling object. What's the only force acting on a falling object? Gravity. So it can either be 16 times T or 9.8 times T squared. What's the difference? The units and which country you're doing it in. In the US, the UAE, we use 16 feet per second squared as the speed of gravity. And in Europe and the rest of the world, we use MKS, which is 9.8 meters per second squared. So let's, since we're in America, we use 16 feet times squared T squared. So our average speed is F of T2, which is 2, minus F of T1 is 0, 2 minus 0. So we have 16 times 2 squared minus 16 times 0 squared. Sixteen times 4 minus 16 times 0. That's 64 over 2 makes it 32 feet per second. That's the average speed of that falling object.
16, like F two equal to 16, 2 squared. How do you get 16 related to like F2?
Because the formula itself is it's gravity times time. Because that's the force acting. Gravity itself is the force, but it has to have time. It's not because how fast can something fall? How fast can a ream of paper fall? How fast can a car fall? Same, 120 miles an hour. Because gravity eventually, once it reaches, it's called terminal velocity, it can't go any faster. So if you ever jump out of an airplane and go parachuting, the fastest you'll ever go is 120 miles an hour. And if you ever look at, sometimes Red Bull they're great at this. They have an airplane doing a nosedive, and they have a parachuters also doing a free fall. They follow the same speed. So what can the parachuter do? They can go back inside the airplane, which is it's amazing. They jumped out of the airplane up here. They both go on a free dive, and then they join back up and they land. Only Red Bull, not YouTube. Red Bull does that. All right. Next one. What's the speed during the 1 second interval between 1 and 2 seconds? So we have 16 2 squared minus 16 1 squared over 2 minus 1. 16 times 4 minus 16 times 1 over 1. 64 minus 16 over 1. 54. 48 feet per second. Why is that? Why in the first one was it 32 feet per second? Now it's 48 feet per second. It has to go with what I just told you about terminal velocity. Has to be, so it's always accelerating, right? So for the first, because the first one was from 0 to 2, it's the overall speed. Now we're looking at what happens in each instantaneous, each section of that till it reaches its 120 miles an hour. Example 2. Same rock falls. Find the speed at t equals 1 and t equals 2 seconds. And I had this. It was because class is over after this question. Time flies. All right, so how do we do this? What are we looking for? What kind of speed? Not average. Because we're looking at, because we're looking at exactly at 1 second. What is it? So it's instantaneous. So remember, our instantaneous formula is what? It's the difference quotient, which is f of t plus h minus f of t all over h. So in our case, this is t. So we have 16 1 plus h squared minus 16 1 squared over h. You ever see how I set it up? Because remember, the function itself is 16 t squared. So the function is 16. So the t is t plus h. The first t is 1. So we have 16. Remember, 1 plus h squared is 1 plus h times 1 plus h. Foiling, 1 times 1 is 1. 1 times h is h. H times 1 is h. And h times h is x squared. 1 plus 2h plus h squared. And 1 squared is 1. So far, so good. Distribute. Sixteen times 1 is 16. 16 times 2 is 32h plus 16h squared minus 16 all over h. Remember, anything after the minus sign has to cancel. So this 16 and that 16 cancel. 32h plus 16h squared over h. Then what? Factor out the h on top. So we have h 32 plus 16h over h. They cancel. 32 plus 16h. Then what happens? H goes to 0. So the instantaneous rate of change at the first second is at the first second mark is 32 feet per second. How did that change from our first one we had? It didn't. Why? Because it's the rate, it's the speed at the end of that first second. That's what we're looking at. It started at 0. Yeah. So what do you think we should, if we had to guess, what do you think at the end of the second second is going to be? It'll be 64 or 48. Is it going to be double or 48? Which do you think? Well, we'll try it anyway. You want to try it or wait till next time?
Okay.
All right, so we have difference quotient 2, which is at t equals 2. Yeah, 2 seconds. Sixteen 2 plus h squared minus 16 times 2 all over h. So 2 plus h squared becomes 2 plus h times 2 plus h. 4 plus 2h plus 2h plus h squared. We have 16 times 4 plus 4h plus h squared minus 16 times 4. 16 times 4, 16 times 4h, 16 times h squared. So 16 times 4 minus 6, those cancel. 16 times 4, 32, 64 h minus 16h squared.
Should I be plus h squared or minus?
Oh, yes, yes, that's right. Good catch. Oh, yeah, it really won't matter if it's gonna go to 0 anyway, but good catch. 64 plus 16h. We factor out an h on the top. 64 plus 16h. And the h goes to 0, so it's 64 feet per second. That's the instantaneous velocity at the end of 2 seconds. That's exactly at that point, because as it's dropping at t equals 0, the velocity is, or the speed is 0. At t equals 1, the speed is, what we say it was? 32. And then at the end of 2 seconds, the speed is 64 feet per second. So it's pretty close. It's going to get to 120 miles an hour. It's growing. It's accelerating pretty quick. All right, so we'll stop here for right now. Let's see. Yeah. And we've talked about most of what's the remainder of this section, but we'll finish it up next time.